Okay, so the sum of a finite geometric sequence is S sub n. It follows the same as an arithmetic. This is just sigma notation right here. So this formula is actually right there. So this is just sigma notation. And if you look at it right here, isn't that the arithmetic definition? A sub 1, r to the n minus 1? Mm-hmm. Yep. So it's a sub 1 times 1 minus r to the n over 1 minus r. Everyone got it written down? Okay, so we need the sum from 1 to 12 of 4 times 0.3 to the I minus 1. Now, if I didn't use the formula, I'd have to plug in 1 through 12 and add those all up. Do you want to do that? I don't. So we have a sub n. How am I going to, or sorry, S sub what? 12, because from 1 to 12, there's 12 things to count, right? Equals, what is a sub 1?
4.
Okay, because we plug in 1, 1 minus 1 is 0. Anything the 0 is 1. So 1 times 4 is 4. Okay? 1 minus r. By looking at the formula, what's r? 0.3. To the n is 12. Over 1 minus 0.3. So this would be 0.7 in the denominator, right? So if I was going to leave this on the test, I couldn't leave a 0.7, so I'd have to move it over and make this 40. So I would have 40 over 7 times 1 minus 0.3 to the 12th. Okay, are you going to have to figure out 0.3 to the 12th? No. Okay, you will have to figure out ones you can figure out, but not 0.3 to the 12th.
Wait, how'd you get the 40 over 7 again?
Because this was 0.7 in the denominator, so I had to move the decimal over 1, so I have to multiply the numerator by 10. So, bless you. So 40 divided by 7 times 1 minus 0.3 to the 12th is approximately 5.71. Remember, when you're putting this in your calculator, put parenthesis 40 divided by 7 parenthesis and then parenthesis again, right? Okay. Let's see the difference here. What's the difference between these two equations?
It doesn't have I minus 1.
It doesn't have I minus 1, does it? This would be a simplified version because we wouldn't leave it like that, would we? Nope. Okay, so S sub what again? 12. What's a sub 1 this time?
4.
Now I plug in 1. So 0.3 times 4 would be 1.2. Remember, you have to plug in your 1 and do the math, because I'm going to tell you right now that's the most mistakes on the test there's going to be when I ask you for a sub 1. You'll just look at it and say, oh, it's 4. It's not always just 4, is it? Okay. And then 1 minus, what's r? 0.3 to the n, 12 over 1 minus 0.3. So this is 0.7. So they both get a move over, right? So I get 12 over 7 times 1 minus 0.3 to the 12th. It is approximately 1.71. Does it make a difference?
Yeah.
Yeah, it's actually going to be exactly 4 different, isn't it? So, other than just plugging it in, are there questions on how to use that formula? You just got to plug in the right stuff, right? Okay, use some sigma notation to write the sum. So sigma is just the sigma, right? It's just this. So is it arithmetic or geometric what we got here?
Or geometric.
It's geometric. Here you're like, ooh, we add 9. But here, did we add 9?
No.
Nope. So R is 2. You guys remember the formula, the definition, the rule? A sub 1 times R to the n minus 1. Okay, A sub 1 is 9. 2 to the n minus 1. And if we simplify that, that's 9 over 2. How'd I get it over 2? How'd I get it over 2?
2 in, and then you have the 2 in, and then...
You have that negative 1, right? So it's 1 over, it's 1/2. So you just put the definition here. Again, if you don't simplify it, it's just a 1/2 point. It's not a huge amount. Are we going to use n or you want to use I? N. So n from 1 to what? We don't know, do we? Do we know the top number?
No.
Nope. So we probably should figure it out, shouldn't we?
Mhm.
So all we have to do is set our definition equal to our last number. Won't that tell us our n?
Yeah.
So let's see. I'd have to multiply by 9/2, right? Or 2/9. 9 goes into 1,152 because it adds up to 9. So 9 goes into 11. How much? Once. With 2. 9 goes into 25. Twice. With how much? 7. And 9 goes into 72. 8. So I just have to take that times 2. But I'm not going to take it times 2 because it equals 2 to the n, yes? So I need to figure out what power of 2 that is. And if I multiply it by 2, I'm just making it bigger, aren't I? So it's time to do a factor tree?
Yeah.
Shoot. So 2 goes into 12, 4, and 8, 2. Actually, how about 6? You guys didn't catch my mistake. 2 goes into, there's 6.
64.
Okay, 64 is a perfect square, isn't it?
Mm-hmm.
But more than that, isn't it 2 cubed times 2 cubed?
Yeah.
Okay, so we have 1, 2, and 6 is what power?
2 to the 7.
8. Because 3 and 3 is 6, 7, 8. Did you forget the one up here?
Yeah.
Okay, so it's 2 to the n equals 2 to the 8. So n is what? 8.
Okay, so on my homework, I wasn't doing that like simplified or whatever 9 over 2 equals
Mm-hmm.
because I wasn't getting them right when I was doing it that way. So when I did it the other way, it was.
Okay.
So
It's just a 1/2 point if you don't simplify them.
okay.
So if you were using 9 over 2 to the n minus 1,
Mm-hmm.
You're going to do the same thing. You're going to divide by 9. So you n minus 1. And then, 128. And then that would be 2 to the 7th, because you have 6, 7. So this would be 2 to the 7th. So n minus 1 equals 7. So n equals 8. So you get the same either way. So all it says is use sigma notation to write the sum. Did I do that?
Yeah.
Right there.
Can we do it like without simplifying it and then simplify it after? Like after we get our answer?
Oh, I don't care. Okay, so let's do the next one. So 15, negative 3, positive 3/5. Well, right away, on a test, I wouldn't tell you it's geometric, but right away, if it's anything, it's going to be geometric and why? Why do?
It's not, because if it was arithmetic, it wouldn't be going back and forth from negative.
Right, if it was arithmetic, it would not be going positive, negative, positive, negative. The only way that can happen is a negative base, isn't it? Okay, so remember I take the second one, so negative 3 over 15, which is negative 1/5. And then I have 3/5 divided by negative 3, which would be negative 1/3 multiplied. So I get negative what? 1/5. So are we going to trust that it's negative 1/5?
Yeah.
Okay, so R equals negative 1/5. It's important you remember that because I give you two numbers. Are two numbers in a sequence enough to know if it's arithmetic or geometric? It's not, because you have to form a pattern, right? So I give you two numbers and I say, tell me if it's arithmetic, like write a definition if it's arithmetic and write a definition if it's geometric. So it's important that you know that it's the first minus the second, and it's the second minus the first, and the second divided by the first. That's how you find those R's and the D's, right? Okay, so we know R is negative 1/5. I'm going to get rid of this so I'm not cluttered. So A sub n equals 15 times negative 1/5 to the n minus 1. So this negative 1 just means I multiply by the reciprocal. So what's the reciprocal of negative 1/5? Negative 5. So I would get negative 75 times negative 1/5 to the n. And then just put it in a sigma. So negative 75
How do you
times.
get 75?
Okay, this negative 1, it's negative 1/5 to the n times negative 1/5 to the negative 1.
Oh, so it made it 5 and then 15.
Yeah.
Okay.
Okay, so now we need to figure out
It's just like that.
this right here equal to one of the two. So you pick one and I'll do one, and we better get the same answer. Do you guys want to do the non-simplified? I don't care. You do it. I'm going to do it. I got 6. You guys get 6?
I'm not done.
What are you using calculators for powers of 5? You are not going to have them on the test. And this would
What
be...
is the highest number that you got, Miss Smith?
I got 625 was the biggest number I got. Did you do the simplified or the non-simplified?
Simplified.
Okay, so look how I did it. I took negative 3 over 625, and it's divided by negative 75, so it's 1 over 75 multiplied by. And 3 goes into 75 25 times.
Yeah, I got that.
Okay, but then you don't multiply them out because you're looking for powers of 5. And I know that 625 is a power of 5, and I know that 25 is a power of 5. So you multiplied 625 times 25, didn't you?
Yeah.
Yeah. Don't do that because we're breaking them down, right? And if you multiply them, you're just going to have to break down this big number. So,
Yeah, 15,725.
Yeah. No. Remember on the other one, I said don't multiply it out because you're wanting to go break it down. So 25 was 5 squared, and 625 is 25 squared. So it's 5 squared times 5 squared times 5 squared. So 5 to the 6th. Don't go multiplying them out when you're going to want to make them like you want the prime factorization. Does that make sense?
Yeah.
Because then you just get... Because I would expect you to do this without a calculator. Because those are all numbers like you know. Okay, so all this says is write in sigma notation. Did we write it in sigma notation?
Yeah.
Yes. Then it could say find it, but this one just says write it. Am I good? No. Am I good?
Yeah.
Okay, so a geometric series, we can find the sum of an infinite geometric series only if the absolute value of r is less than 1. Only if. So you can find the sum of an infinite geometric series only if what? The absolute value of r is less than 1. That's important to know. And the reason we can do that is because if r is 6 and I take it to some n, what's going to happen? It's going to get bigger and bigger and bigger and bigger and bigger, right? Mm-hmm. But what if I say it's 1/6? Well, 1 is just 1, right? Any power of 1 is 1, correct? Mm-hmm. What do you think, like, 6 to the 10th is? Big, right? It's actually 1 over 604,66176. 60,466,176. How big is that number?
Too big.
Well, yeah, but that's 1 over that number. What is the whole number?
Less than 1.
Way less than 1. It's almost what? 0. If I divide 1 by 6 to the 10th, I get 0.1234567165338. That number is pretty close to what? 0. And that's only 6 to the 10th. That's not even a very big number, is it? No. So what happens is when I use my formula right here, this r to the n basically becomes what? 0. Well, 1 minus 0 is what? 1. So my formula just becomes what? Oops. 1 over.
So is it always gonna be 0?
Yeah, if, only if, the absolute value of R is less than 1. And here's your formula right here. Oops. I touched it twice. So this time we're finding S. What's missing? What's missing from all the other formulas that you had for summation? N. Because there is no finite. It's not finite. It's infinite. So if you just see an S, it's asking for the what? Sum. The infinite. Okay? This is just summation notation. The actual formula is right here. And on the other screen, I had a sub 1 times 1 minus r. Or 1 divided by 1 minus r. Well, what's 1 times a sub 1?
1.
What's 1 times a sub 1?
A sub 1.
A sub 1. That's why the formula shrinks down to just a sub 1 over 1 minus r. And it only works when?
It's less than 1.
Okay. What's less than 1? R. The absolute value of R is less than 1. Oops. That's written wrong. It's up here. I underlined the wrong one. Okay. So it's the infinite sum of a geometric series. Has to be geometric. Yes, first. And then R has to be, the absolute value has to be less than what? 1. Now, if it is greater than equal to 1, is there an infinite sum? No. So be careful that there might be some trick questions, right? They might ask you to find the sum. If they just say the sum, they want the sum of it all, right? And if there is an infinity sign up here, is it possible that you say doesn't exist or undefined? Yes, and you have to tell me why. If it's undefined because it's arithmetic, you say it's undefined. You can't find the sum of an infinite arithmetic sequence, right? If it's undefined because R is greater than equal to 1, so you say undefined and you say 3 is greater than equal to 1. And are those your reasoning? Yes. You guys all got the formula? Okay, so find the sum. And I know it's infinite because of what is on the summation? An infinity. I know the second one's infinite because what?
The dots.
The dots. Okay, the sum from n is 0 to infinity of 4 times 0.6 to the n. First off, is it geometric? Yes. So geo, check. Is R, what's R? 0.6. Is 0.6 less than 1? Is the absolute value of 0.6. So that's a check. So can I do this then? Yes. So S equals a sub 1. How do I find a sub 1?
Put 1 in for n.
Not 1. Not in this case. Put 0. Put the lower limit. A lot of times it's 1, but not always. So 0 in for n, so 0.6 to the 0 is 1. 1 times 4 is 4. Over 1 minus r is 0.6. So that gives me 4 over 0.4. So I have to move my decimal, so it makes it 4 over 40. So S is what? 10. Now, is it ever going to really be 10? No. But we're going to get so close to it, we can't tell the difference. Make sense? Those are what limits are, and calculus will go over those.
This is not sound fun.
It isn't bad. Okay, so
About everything.
3 plus 0.3 plus 0.03, 0.003. Okay, well, is it geometric? Yes, it is geometric. What is R? Well, R would be 0.3 divided by 3, which would be 0.1. Yes. Let's check it. So it'd be 0.03 divided by 0.3. So move once, and you still get 0.1. So is the absolute value of R less than 1? So we're good to go. So S equals, this one we don't have to plug in. What is 1? It's a 1.
Or what?
What's A sub 1?
3.
3. Over 1 minus R, what's R? 0.1.
1.
So that gives me 3 over 0.9. So it gives me 30 over 9. Or 10 over 3. Right? That's it. So you got 2 formulas today. What's this one? What's the name of it?
Infinite geometric.
The sum of an infinite geometric. What's this one? The sum of a finite geometric. I'm pretty sure we finished the notes. Yep. Wait. Yep, that's it.